So this lecture is on how the internet works. So how exactly do computers send data? Here in the image, you can see two people in different parts of the world communicating with each other, probably through the internet. Now, individuals can connect to the internet through their ISPs, which can be their telecommunications company, cable television company, satellite, or school or office. Now, communication channels can be using your telephone for those of you who are still using dial-up, which I don't think there are any anymore, at least here in the Philippines, at least in the major municipalities. Then there's also the digital subscriber line, which is probably what many of us are using now. There's also the ISDN, which is probably still being used by some companies. There's the ADSL, the T1, T3. These are basically high-speed internet and high bandwidth internet service connections. There's also cable, wireless, and satellite. Now, for those of you who are familiar with the modem, at least in the old modem, what they did was for analog modems, digital data was converted by the transmitting modem to analog data, which is transmitted to the receiving modem. The signal is converted back to digital data using modulation demodulation. Digital modems do not have this since they're already digital to begin with. For those of you who use dial-up modems, what would happen usually is nobody can use the telephone except for you. You. While you're connected to the internet, you and you alone could use a phone. Naturally, if somebody picked up the phone and started dialing without listening to the traffic, they would probably end up accidentally disconnecting you. Although I don't remember if this is actually what happened in the past, because anybody lifting the phone would usually hear very loud squeaks of sound, and usually this already told people that somebody was using the phone for to connect to the internet. Now, digital subscriber lines, this is what you normally use nowadays. Now, what is ADSL? Now, ADSL is asymmetric DSL, which means that there's a difference between the upload and the download speeds. Usually or traditionally, there's a slower upstream or upload, and there's a trade-off, and downstream or the download speed is usually faster. Now, depending on your connection, let's say your upstream can be from 128 to 640 kilobits per second, and your downstream could be 1.5 megabits to 6 megabits per second downstream. So naturally, the trend before was that chances are you would be requesting for more data and uploading less. However, nowadays, since we're a world wherein we love to upload information, chances are this notion of having a slower upstream might not be as common or as advantageous as it was to the ISPs. But naturally nowadays it's no longer balanced. Anyway, so cable modems use use coaxial cables to carry TV signals and high-speed internet access. Most of you probably are using DSL anyway. Back then, at least for us, we had the Destiny cable, and I think Sky Cable had their own ZPD cable to combat Destiny cable. However, I think Sky Cable already purchased or is the majority shareholder for Destiny cable, so nowadays it doesn't really matter. Now there's also cell phones or PDAs that are used for mobile computing. As you can see from these slides, some of these slides are actually very old and use devices that you probably don't see anymore. The one on the right is the Nokia cell phone. It's like 7110, I think. And back then, this is what people wanted. Even I wanted this. As for the one in the middle, that's a Palm Pilot connecting to a very high-end Nokia cell phone using infrared to connect to the internet. And then you have on the rightmost side, you have a Palm Pilot connecting to a printer through a cell phone or through a computer. Now, delivering a message over the internet uses the packet switching system. When delivering information via the internet, the information is split into small units called data packets. The data is reassembled at the destination. Now, a data packet is continuously routed from the source to the destination. Now, an important concept to learn is the IP address. Each computer in the internet is assigned a specific and unique number for identification. In fact, if you're connecting to your router at home and you're using static addresses, there's a good chance that you might get an error if you have two computers that are using the same IP address. You're going to get a warning in your computer saying that there's already somebody with the same IP address on the network, which will create difficulty since anybody trying to connect to your IP address, and since, well, there'll be a problem since there's two of you with the same IP address. It's like two students in this class having the same first name, and when I shout or when I call the attention of that particular student, both look. So this is somewhat similar to that. Now, the, the number is called the IP address of the specific host or computer, and there are four parts to the IP address, and they range from numbers 0 to 255. And here you can see the examples. Assignment is either static, fixed, or dynamic. Now, dynamic is what happens when you just connect to a network at random and it assigns you a number. Now, sometimes you might want to have it static. This is helpful, especially if, let's say, you plan to have a web server at your home and you want to be able to connect to it from the router. I'll teach you that later on. And also, for some businesses, they might want to have a specific IP address assigned to them so that anybody who connects to that address can access their systems. Now, the IP address is split into two parts, the network number and a host number. So, for example, 198.70 is the network number, and then the host number is 185.3. The inter-NIC hands out assigned addresses to the public. Now, for IP routing, the process of transmitting the data packet from the source to the destination via a series of intermediate stations is called routing. IP routing works as follows. Each data packet is labeled with an IP address of the destination host. However, if the data is huge, it is disassembled into smaller packets, and the order is distinguished by sequence numbers. At the destination, the packets are then reassembled in the same order. Now, this concept you'll hear a lot, if not already at all. The TCP/IP, it's basically two protocols that work together. The first one is a TCP, which is Transmission Control Protocol, which takes charge of breaking up the packets and messages, then reassembling them at the destination. The IP, which is the Internet Protocol, would be responsible for transmitting the individual packets. For example, the TCP protocol would split up the message and place it into multiple envelopes, while the IP protocol would be in charge of addressing the envelope and making sure it arrives at its proper destination. Now, a protocol is a connection for rules for formatting, ordering, and error checking data sent across the network. Vinton Cerf and Robert Kahn developed the Transmission Control Protocol / Internet Protocol and was used as a standard protocol for the Internet. Because of the significance of this, these two are considered as the fathers of the Internet. Now, what is the notion of packet retransmission? Now, sometimes, naturally, a packet can be lost during the transmission across the Internet for whatever reason. It could be that the host is down, there's the, the, the data packet was sent to an area or through a computer that was turned off for some reason, or there's a failure in the link. Anyway, when the destination host has been waiting for a particular packet for a certain time, it eventually times out and it will request the source host to retransmit the package. It's like, if you think about it, it's like your mail, or let's say you ordered something online. If you ordered several items and one of the items didn't get to you, you're going to make a request to have the packet sent again. Naturally, that's not in the realistically that doesn't really happen. in uh, in the type of setting. However, here, since this is just data, it can be resent numerous times. What's important is that eventually you will get it. Now, there is no need to retransmit all the data packets. Instead, only the missing packet, which is identified by the sequence number, needs to be retransmitted. Now, for error detection, there's a concept called checksums. Now, transmission errors can occur even if the data packet is received by the destination successfully. So, how do we ensure that the data is correctly received? There's a method to detect possible transmission errors. At the destination, checksum is recalculated based on the received data. The attached checksum and the newly calculated checksum are compared, and any mismatch means that there is a transmission error that occurred. I will not be able to discuss this at this point in time since it's better off shown physically or when we do our face to face. Now, what is DNS? DNS is the domain name system. Because IP addresses is difficult is well, it's difficult to remember actually. I'm sure that none of you know the IP address for Google. They might actually have several IP addresses just to make sure that there's no congestion. Yahoo has their own IP address. All the websites you go to has their own IP addresses. Now, naturally, nobody remembers these IP addresses. It's easier to remember Yahoo, Google, and all that. Apple, Google. Anyway, so what happens is names are given to each computer on the internet for the convenience of human users. Besides IP addresses, all internet applications allow users to use computer names. And the main names are usually separated by dots. Now here's an example of the IP versus domain name. So the IP address is a specific set of numbers and the domain name is naturally unique also. So what happens is when you type the domain name on your computers, your browsers already know the location of the domain name server. And what it will do is it is going to ask the domain name server for the IP address related to the domain name that you're requesting. And then hidden from you, the browser is going to request for information from that IP address that you were going to. Now here are example of top level domains: edu, com, gov, mil, org, net, and although at the time the slide was made, there was already the .xxx. Well, it was still undetermined. Now actually it exists, and there's also a lot of others. .asia I recently saw online, and there's some specific for specific countries or specific, I guess, hemispheres. Now URLs are known as uniform resource locators. It's a web addressing scheme that tells the exact location of an internet resource. And this is the following format. You basically type the URL on the browser's address bar. Now here are examples of some services provided by the internet. You have FTP, Telnet, email, news groups, and the popular www. And Gopher is already, it's something that's antiquated already. Now, www is a series of servers that are interconnected through hypertext. And hypertext is a method of presenting information in which when certain highlighted text called hyperlinks are clicked, it displays information about the topic. A browser allows the user to navigate the web by typing the URL on the address bar or by clicking the hyperlink. Some useful services on the World Wide Web are email, search engines, knowledge base, basically everything now. But at this point in time, it's used. I'm sure you can come up with more on your own.